Greetings, pre-calculus students, to another day in our unit on sequences. In today's lesson, we will cover a special type of problem that you can encounter when dealing with arithmetic sequences. And then I'm going to introduce you all to a new type of notation that you most likely have never seen before. But before that, I just wanted to, just in case the bell ringer was not reviewed in class, I did want to just quickly go through the bell ringer where you're given a sequence, you're asked to determine if it's arithmetic or not, and then if it is arithmetic, you are tasked with writing an explicit formula as well as a recursive one. So let's just quickly go through this one. You'll see that this sequence is indeed arithmetic because the difference between each consecutive terms is plus 7. Okay, we just add 7 between each consecutive term. So that means it is arithmetic. Okay, so we do know it is arithmetic. Yes, arithmetic. Because common difference equals 7. So it is arithmetic. And then we're tasked with writing an explicit and recursive formula. So let's do the explicit first. We talked about how to write an explicit formula for a arithmetic sequence. Remember, it has the form of a linear equation, in other words. So a sub n is equal to dn plus c. D is just your common difference, or your slope, in other words. So in this case, the common difference would be 7. And then the plus c would be your quote-unquote zero term. So what would be the term before the first term? Well, if we went backwards, right? If we went backwards, that means the zero term, quote-unquote, would be 3. Right? That would be the term before 10 if you did the pattern backwards. So that means our c value is 10. So that is our explicit formula. Oh, wait a second. Whoops. Did I put plus 10? I meant put plus 3. That is our explicit formula. Now let's quickly do our recursive. So our recursive formula, it would be a sub 1 is equal to 10. Remember, you do always have to specify what your first term is. And then the actual pattern itself would be a sub n is equal to a sub n minus 1, because that's your previous term, plus 7, since the pattern is just adding 7. So that's just a quick run through, just in case the bell ringer was not covered in class. All right, so let's get to the lesson itself. So recap from yesterday. An arithmetic sequence, from the previous lesson. An arithmetic sequence is a sequence whose consecutive terms have a common difference. Okay, so given any two terms in the sequence, the difference is always the same. So whether I choose the second term and the third term, or the 49th term and the 50th term, the difference between those consecutive terms is always the same. So just think of it as a linear pattern, okay? You're always adding or subtracting the same amount every single time. So let's look at a specific type of problem that you can encounter when dealing with arithmetic sequences, and it's this one. The fourth term of an arithmetic sequence is 20, and the 13th term is 65. Write an explicit formula for the nth term of this sequence. So, very different than what we've seen in the past. So, as opposed to giving us a list of numbers or a sequence of numbers, now they just specify what is the fourth term and the 13th term. And we have to figure out what the explicit formula for this would be. Now, we are told that it is arithmetic, so they do tell us that. They do tell us that. So, let's see. So, we're given the fourth term, so that is 20, and then we're given the 13th term, so that's 65. Okay, so we're given those two terms, fourth term and 13th term, and we're told that it's arithmetic. Okay, we're told that it's arithmetic. Well, it's important to remember what an arithmetic sequence is, and we just talked about that in the previous slide. An arithmetic sequence has a common difference, right? You're always adding and subtracting. The difference is always the same. It's constant. You're always adding or subtracting by the same amount every single when moving from one term to the next. So how do we do this? We have to write an explicit formula. Well, we just talked about that the formula has to look something like this. So a sub n is equal to dn plus c, so a linear equation, in other words. So we have to figure out what the d and c term are. All right. How do we figure out what the d and c term are? Well, let's try to figure out what the difference is first. And to do this, we really have to focus on this idea that it is an arithmetic sequence. So we know that 20 goes here, and then the 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, and then the 13th term, 65. All right. So we don't know everything. We don't know all those terms in between. We don't know the 5th, 6th, 7th, all the way up to the 12th. We don't know all those terms, but we know the 4th and we know the 13th. Well, once again, we do know something, though. We do know something. We know that since it is arithmetic, the difference always has to be the same, right? It's always going to be the same amount every single time. So what do we know about that difference? Well, we know it's a number, right? We know it's a number, and we can just call it D to synchronize with what the explicit formula is. Let's just call it D. Well, we know to get to the next term, we take 20 and we add that number, right? We take 20 and we add the number. So we add D, in other words. Okay? So that means the next term is 20 plus D. We at least know that. D is that difference that we don't know what it's equal to, but we do know that. And then if we were to continue this, right, that means the next one would also be plus D. So how would we find the next term after that? Well, we would take the previous number, which in this case is now 20 plus D, and add another D to it, right? So it would be 20 plus D, and you can add those two D's together because they are like terms. So that means we would end up with 20 plus 2D. And you might notice what you can see is happening here. We're actually going to continue with this process, right? Plus D, plus D, plus D, and then we just keep on going, right? So that means the next one would be 20 plus 2D, because that was the previous term, plus another D. So that would be 20 plus 3D. Okay, once again, we don't know what D is, but we know it's a number, and we know it represents the difference. And we're going to continue this on. So the next one would be plus 4D, and then plus 5D, plus 6D, 7D, and then looks like I'm kind of running out of room here, 8D. And we can actually say something about 65. 65, according to this pattern, 65 would be the same thing as 20 plus 9D. All right? 65 would be the same thing as 20 plus 9D. So now we can set up an equation. Now we can say 20 plus 9D is equal to 65. Because according to this, what's the word? According to this sequence that we just have, right, we ended up with, in the end, that 20 plus 9D has to equal to 65. Right? That has to be true according to our pattern of numbers, our sequence of numbers. So now we can actually solve this. We can solve this for D. So subtract 20 from both sides, and we end up with 9D is equal to 45. So 9D is equal to 45. So now we can divide both sides by 9, and it looks like our D value, which recall is our difference, our common difference is equal to 5. Okay, our common difference is equal to 5. So we at least have this so far. We have 5n plus c. So 5n plus c. So we found our D value. Now we still have to find our C value, though. Well, our C value, remember, is the 0 term, quote unquote. We know the fourth term, so we got to figure out what would the 0 term be. Well, let's just go backwards then. We already know that the D value is 5, so we already know the pattern. We already know the pattern is plus 5. Well, let's go backwards. So remember, this is the fourth term. So if we go backwards, let's see, it would be 15. And then I'm going to erase these at this point. It would be 15, then 10, then 5, then 0. So let's see. So that would be the third term. That would be the second term. That would be the first term. So this is the 0 term, which just so happens to be 0. So that's our C value. That is our C value. Our C value is 0. So that means our equation, just erase the C now, our equation is 5n plus 0, or just 5n, right? There's no point of writing on a plus 0. We can, but we don't have to. Okay? So that's one way you could have found C. There is another way you could have found C. You could have also found C by doing this. We knew that this was our formula so far. Well, once again, we know what the fourth term is, right? We know the fourth term is 20 because it tells us in the problem. So we could have also done this. Since the fourth term is 20, that means 20 equals 5 times 4. Because remember, that's the n value, so that means the 4 would go in for n plus c. So now you would have another equation you could easily solve. You would have 20 is equal to 20 plus c. If we subtract 20 from both sides, that means c would have to be 0, which is what we got, right? So that's another way you could find c. So not only can you find c by just finding the 0 term by moving backwards, you could have also found c by using one of the numbers given to you, so either the fourth term or the 13th term, and plugging it into the equation and solving for c. So you could have also done it that way. Okay. So just a special type of problem when it comes to arithmetic sequences. So this next problem I want you to do on your own. So this checkpoint 1 problem I want you to do on your own. So it's just like the previous one, except now they give you the 8th and the 12th term, but the idea is still the same. All right? So this one on your own. All right. Now let's look at a special type of sequence here. Try to identify the pattern in this sequence. 1, 2, 6, 24, 120. 1, 2, 6, 24, 120. Might be a head scratcher. Well, let's try this first. Let's try finding the difference between the numbers. Well, let's see. The difference here is 1. Difference here is 4. Difference here is 18. And difference here is 96. Yeah, that doesn't look like it's helping us. Well, let's try to find the second difference. Difference here is 3. Difference here is 14. Difference here is 78. It still doesn't look like it's helping us. The third difference? 9. Oh, I'm sorry. 11. 64. Yeah, it doesn't look like we're getting anywhere. Okay, so finding the differences doesn't help. Let's try dividing. That's something that we've not tried to do. Let's see what happens if we divide consecutive terms. So what happens if we do 2 divided by 1? Well, 2 divided by 1 is just 2. All right. What about if we do the next one? 6 divided by 2. 6 divided by 2 is 3. All right. What about the next one? 24 divided by 6? 24 divided by 6 is 4. Huh. Interesting. Is 120 divided by 24 5? I wonder. 120 divided by 24? It is 5. Interesting. So it looks like we're always multiplying by the next integer. So to get from 1 to 2, we did times 2. To get from 2 to 6, times 3. 6 to 24, times 4. 24 to 120, times 5. So the next one would be times 6, which would be 720. Interesting. So this is where this new notation comes in, because there is a way to describe this kind of multiplication. There is a way to describe this kind of multiplication where you're always multiplying by the next whole number, in other words, or the next integer. And here it is. Factorial notation. So if n is a positive integer, so remember an integer is just a whole number, n factorial is defined as this expression or this equation. So a couple things to make note of. The first is this, n exclamation point, okay? Exclamation mark. So whenever you see that notation, whenever you see a number, or in this case a variable, with that exclamation mark, it has a significance, and it is called a factorial. And it's basically, you're just multiplying all the numbers, all the consecutive integers, all the way up to whatever n is. Okay, so for example, let's say this is what you had, 7 factorial. That's how we would read that, 7 factorial. That would be the same thing as 1 times 2 times 3 times 4 times 5 times 6 times 7. So you're doing the product of all the integers up to that number. Okay, the product of all the integers up to that number. So if it was 8, you would go 1 through 8. If it was 10, you would go 1 through 10. If it was 4, you would just go 1 through 4, so on and so forth. Okay, so that's all that notation is. And then the special case is 0. Whenever you see 0 factorial, that's actually 1. It's not 0, it's 1. And then, like I said, that's a special case. Okay, so whenever you see 0 factorial or 0 exclamation mark, that is equal to 1. Okay, so that's a special case, special property. So in terms of using this in this class, you'll never be required, at least in this class, you'll never be required, outside of an extra credit question, you'll never be required to figure out that a pattern involves the factorial. Okay, like for example, this pattern involved multiplying by always the next integer, so that's how we knew it was it would involve a formula involving a factorial, but you do need to know how to use this notation, okay, which we'll do in the next example. So example 3, write the first 5 terms of the sequence given by a sub n is equal to 2 to the power of n divided by n factorial. Begin with n equals 1. Okay, so this is what I mean. You have to be able to at least use it, evaluate it, actually compute what it's equal to. So let's do the first 5 terms. We've done this before. So a sub 1, sub 2, sub 3, sub 4, and sub 5. And it tells us in the problem to start with 1, so we're good there. All right, so a sub 1 would equal to, actually no, let me do this. Would be equal to 2, oh, messed up already. Would be equal to 2 to the first power over 1 factorial. So 2 to the first power is just 2, and 1 factorial is just 1. Because you're basically going all numbers from 1 to 1. So that would just be 1. So that'll just be 1, so that's 2. Okay, let's do the next one. So the next one would be a sub 2, so that means 2 goes in for n, so 2 squared over 2 factorial. So 2 squared is just 4. 2 factorial would be all integers from 1 to 2. So that means 1 and 2. Or the product of all integers from 1 to 2. So 1 times 2. So this gives me 4 times 2. This gives me 4 divided by 2, which is just 2. Okay? Let's do the next one. A sub 3. So this gives me 2 cubed over 3 factorial. Well, 2 cubed is 2 times 2 times 2. So that's just 8. And 3 factorial is 1 times 2 times 3, right? All integers, or the product of all integers from 1 to 3. So that'd be 8 over 6, which is 4 thirds. 8 over 6, which is just 4 thirds. All right? Next one, a sub 4. So that's 2 to the 4th power over 4 factorial. So 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. And then 4 factorial is the product of all integers from 1 to 4. So 1, 2, 3, 4. So what is this? This would be 16 over 24, which if I were to simplify it would be 2 thirds. And then the last one. The last one would be the 5th term. So 2 to the 5th power over 5 factorial. So once again, 2 to the 5th would be 32. 2 times 2 times 2 times 2 times 2. And 5 factorial would be all the product of all integers from 1 to 5. So 32 over 120. So 32 over 120, let's see, how does that simplify to? Trying to think if I know off the top of my head. I think it would be 8 over 15. Yeah, 8, no, I got that wrong. 8 over 25. 8 over 25. 8 over 25 if you divided both 32 and 120 by 4. So those are the first 5 terms of this sequence. 2, 2, 4 thirds, 2 thirds, 8 over 25. All right? So like I said, you will need to at least know how to use the factorial. But in terms of actually being given a sequence already and trying to determine what the pattern is, that outside of an extra credit question, you won't need to do. Okay? And then the next question, checkpoint 2, I want you to try on your own. So this is your chance to try out to see if you know how to use this factorial. Should be relatively simple. Just writing the first 5 terms, just like the previous example. Okay, so this one is on your own. Okay? And then one more on your own problem is this next one. So a little vocab check I want you guys to try out. See if you know what each of these mean. So sequence, explicit formula, recursive formula, arithmetic sequence. So can you describe each of these as best as you can in your own words, as best as you can. You know, there's nothing wrong with looking back at your notes and looking at the definitions, but trying as best as you can to describe these in your own words, and then writing an example for each. So like, give me an example of what a sequence would look like. Give me an example of what an explicit formula would look like, so on and so forth. Okay? So this one I also want you to try on your own. Okay? This one I also want you to try on your own. So just a little quick vocab check to make sure you're familiarizing yourselves with all the different vocab words we've learned this past week or so. Otherwise, that is the end of the lesson. So like I said, make sure you complete those on your own problems. Otherwise, if you have any questions, please reach out to me through whatever channels you feel most comfortable with. But otherwise, I hope you guys stay safe, and I hope you enjoyed the rest